Okay, this will be the video guide for page 2 for Algebra 2 review for test number 5. We're going to start with number 9, and the directions are simply to solve by factoring. So we're just going to pick up where we left off on page 1. The difference with this problem is that we have a leading coefficient, and so we need to multiply this 3, this a value, times this c value to find out what we're factoring toward. So if we multiply 3, wrong button. If we multiply 3 times 56, that gives us 168. Then we have to find factors of 68 or 168 that add to negative 17. The only way that's going to happen is if one of those, it's negative because that was negative 56. So we're looking for factors of negative 168. So one of these two numbers has to be negative, and it's going to be the larger one because we have to end up with a negative 17 value. So let's find the factors. Obviously 1 and negative 168 would work. 2 and negative 84. 3 and negative 56. We're still not adding up to negative 17 yet though. So 4 and negative 42. I'm just finding these by dividing 168 by these numbers and seeing what we get. If you get something that's not a whole number, don't use it. Not a factor. 6 and negative 28. We're getting closer because negative 28 minus 6 is negative 22, but we're still not negative 17. 7 and negative 24. And this is the pair that we're looking for because negative 24 plus 7 is negative 17. So that's what we're going to hang on to. So now we're going to start splitting this middle term. Actually, so it's 7 and negative 24 is what we're looking for. Get rid of that other work. Alright, so we keep the 3x squared, we just bring that straight down. And we're going to also bring down that negative 56, so we're not messing with that. What we're doing is we're splitting this negative 17 into negative 24x and 7x. So if you add those together, you haven't really changed the equation. You're just breaking that 17 into two terms. So now we can group these. So if we group this and this, and then we take out the GCF, in this case that would be 3x, and we're left with x minus 8. And then if we can take out a 7 from both of these, and we're left with x minus 8. All of that is still equal to 0. Now we can recombine the 3x and the 7, so that becomes 3x plus 7. And then the x minus 8's come down as 1. So now we've factored, and we just have to solve for each of those. Set each equal to 0, and solve. And we'll get our two solutions. And we're just using simple algebra now. Solve. So one solution is going to be x equals negative 7/3. The other one We just add the 8 to the other side. And we have x equal 8. And that is solved. So we have our two solutions. You can look at that, or you can pause to look at that, or we can move on to number 11. Okay, so we're going to go through number 11. When we first look at this one, the numbers looked ridiculous. Like the math is going to get too big, but don't panic. You need to notice that these might have something we can take out first to simplify or make the numbers smaller. So let's do that. So let's take out, in this case, each of these is divisible by 4. So let's factor out a 4. So that leaves 8p squared minus 65p plus 8 equals 0. All I did was divide each of those by 4 to get the 8, the negative 65, and the 8. If you see that they're even, you just divide by 2, you'd still end up with even numbers, and you divide by 2 again, you'd still get back to this. All right, so now we're ready to do what we did on number 9, which is we're going to multiply 8 times 8 to find what will give us our number that we're trying to factor to. So 8 times 8 is 64, so we want something that two numbers that multiply to 64 and add to this middle number, which is negative 65. Now in this case, if we have a negative in the middle that we need to add to a negative, but we must multiply to be positive, both numbers need to be negative. That's the only way it can happen. A negative times a negative is a positive. A negative plus a negative can be negative. I'm sorry, a negative plus a positive can be negative. I said that wrong. A negative plus a negative can be negative. All right, let's move on. So, what are these numbers? Well, the factors of 64 are 1 and 64. And if those are both negative, they give us what we need. Negative 1 times negative 64, it gives us 64. And negative 1 plus negative 64 is negative 65. Those are the numbers we're going to use. So I'm going to write those up here. Get rid of that. All right, let's move on then. So now we can get rid of that 4. And now we're just going to split this middle term. It would help if I had a pen turned on. I'm going to split that middle into negative 64p, that's a 6, and negative 1p. And then we bring these other numbers down as they were. 8p squared and plus 8. And here we go again. We're just going to group because we have 4 terms and take out the GCFs. So that'll give us what the biggest number I can take out of 8 and 64 is 8. And the biggest variable I can take out of p squared and p is p. And I'm left with p minus 8. And then over here, the only thing I can do is take out a negative 1. And I'm left with p minus 8. Because if I divide negative 1p by negative 1, I get p. And 8 divided by negative 1 is negative 8. This is good because these two terms match. And those will come down as 1. Give us p minus 8. And then we're going to combine the 8p minus 1. Cannot write today. And it's all still equal to 0. So at this point, we're going to set each of these equal to 0 and solve. I'm going to do that up here. (8p minus 1 equals 0) and p minus 8 equal 0. These are all still for this problem. Add 1 to both sides. 8p equal 1. Divide by 8. P equal 1 over 8. And then add 8 to both sides here. P equal positive 8. That's our answer. So you can hit pause and look at that and work on that, or when you're ready, hit play and move on to number 13. Alright, with 13, this is another one with large numbers. We see that they're all even. They're at least divisible by 2, but it turns out they're divisible by 4, so I'm going to do that. Take out a 4. We're left with 3r squared minus 7r minus 40. All that's equal to 0. And then 3 times negative 40 gives us negative 120. And that's what we have to find factors of. So we want something that multiplies to negative 120, adds to negative 28. I'm going to start running down the list of factors of 120. Now we need a negative, and we want a negative in the middle. So 1 has to be negative, 1 has to be positive, because a negative times a negative would not give us a negative. So I'm going to go, again, the negative one has to be larger, because we have to end up negative on the whole. So I'm going to go with 1 and negative 120, 2 and negative 60. You're going to stop me when I get to something that adds to negative 7. 3 and negative 40, not even close. 4 and negative 30, still not close. 5, negative 24. 6, negative 20, getting closer, we're at negative 14. 7 doesn't go in to 120. 8 and negative 15. And then if we add those together, we get the negative 7. So those are our factors we want to use. I'm going to get rid of that, write those up here so I know that's what I want. 8 and negative 15. So I'm going to split that negative 7r into. Alright. Let's keep working then. So we're going to split negative 7r into negative 15r plus 8r. You add those together, you get back to the negative 7. Bring down the negative 40. Bring down the 3r squared. And now let's group. And take out GCFs. So we can take out a 3r. And we're left with r minus 5. We can take out an 8. And we're left with r minus 5. Again, that's good that these two match. So now we can recombine. 3r plus 8. And r minus 5. At this point, we're still equal to 0. Set each of these equal to 0 and solve. You may want to hit pause and go ahead and do that. I'm going to just work through that, work real quickly up here. And there you go. Those are our two solutions for number 13. That's it for page 2. So if you want to move on to the next video, if you need help with page 3, I'll see you there.